Right. So next topic is ABC analysis. So ABC analysis is a technique to group the items in inventory that we have into really important items or really critical items, non-critical items, and somewhat critical items. So A would be the, well, here for our purposes we will be using the amount of dollars spent on the inventory items. So the larger the dollars spent on a given item, you want more close monitoring so we don't end up wasting money. So cost, to keep the costs down, we want really very close monitoring. Whereas the items on which we spend very little money, okay, if you're closely monitoring, the possible benefits of very close monitoring is very small, and it may even be cost ineffective. So might as well have broad um, decisions about how much to stock and stuff like that. Even if you have inefficient level of safety stock, and inventory carrying cost becomes relatively high, and still because the item cost is so low, it's not going to be really a problem. So that's the idea. So the idea here is typically if you look at companies, and empirically this can be seen, that a small part of your inventory will cover a large amount of dollar value spent on inventory. So if you focus your managerial resources on these few items, then the potential for cost saving is really high. All right, so about 70% of dollar value. So you spend all your mistakes can be expensive in this. If you make mistakes, and the cost can be really high, and therefore all your managerial attention and energies and focus, like forecasting and safety stock, fine tuning the safety stock and making sure the variability is low, and these kinds of close monitoring the energies for close monitoring can be reserved for these items. Now on the other hand, group C items, so that's A, and on the third item, group C, is low cost but high volume, in the sense there are lots and lots of items. So it's typically about 50% of the items will have like 5% of dollar amount that is being spent. So it is not cost effective to spend too much time on managing those items. So simple control procedures is sufficient. Automated controls is okay for that, because even if you make mistakes, the cost of those mistakes is not going to be huge. As a matter of fact, not avoiding mistakes may require more cost than the cost of the mistakes. And in between, about 20% of the items represent about 20% of the cost. Those are called B items. So you have group A, group C at the bottom, and then in the middle you have group B. And so here is the rule. Okay, and one thing we need to realize that these are not exact rules. Like you're not going to go and say exactly 70% of dollar usage, and is it equal to exactly 10% of the items? No, it may not be, because these are two different independent rules. It's very likely that for a given situation, only 50% of dollar usage will constitute 10%. If you take 10% of the item, that only accounts for 50% of dollar usage. So, and similarly, these numbers can be a little fudgy. So you have to try to manage it, try to fit these thumb rules, these are thumb rules, as best as you can. Do not expect it to be exactly like this. So these are general broad guidelines. So what we have to do to classify the items is we have to figure out the cumulative dollar usage and cumulative number of items, and try to fit this rule as best as we can. Okay, so let's look at an example. Okay, so let's assume that we have 14 items. So we want to keep the problem reasonable. Usually you'll have hundreds if not thousands of items, but we have 14 items, and we have the annual demand from the previous year, and we have the cost per unit. Okay, so we want to keep this as is, so I'm going to copy paste these items over here to do the computations. Okay, so all right, so now what we have to do is to find the annual dollar usage. Annual dollar usage is demand times cost per unit. So that will give us the how much money we spent on each of these items over 1 year. Okay. So if you add that, if you sum these values, then that tells us what is our total dollar expenditure on inventories in 1 year. Okay. If you divide that, okay, let's put the border back. If you divide that into each dollar value, okay, that divided by that, and of course we have to absolute reference that, and let's make that into a percent. All right, so that gives you the percentages. All right, so now we want annual dollar percentage cumulative, so this should be cumulative. Okay, cumulative annual dollar percentage, and you can do that by summing, okay, that with K7 to K7, except the first K7 you need to make that absolute reference. All right, so then it'll always, the summing will always start from there to down. So that's 100%. Okay. So the number of items percentage cumulative again, so that you can divide the total number of items into the item, the number in the row, so that will give us how many items are there from top to bottom. Okay, that divided by that should be absolute referenced. Okay. Okay. Now for us to compare the rule, we need to really sort this list by the largest annual dollar usage to the smallest at the bottom. Okay, so we want to do it only for that part. Data sort. All right, so my data has headers, so you see the headers, annual dollar usage, but you want largest to smallest in descending order. Okay, so now we have, so let's put the border back. All right, so now we have set up the dollar usage and percentage usage. Now we have to apply the rule. Okay. And remember, this is only a thumb rule, so 70% and 10%. So if you look at 10% here, so that's only the first two items of 10%, and that constitutes only 54%. Okay, if you want 70%, you should go up to here, and that has way too many A's. So we have to compromise here. Right. So to compromise, we can look at the dollar usage and see, okay, the difference. Okay, we know that that is A and that is A for sure. Now the question is this A as well, or that should be B? Because at this point, if you have that as A, you get to 20% of items, and that gets us closer to the 70%. And if you look at the dollar usage, it looks like this is closer to an A item than it is to a B item. So maybe you should include that as A. Okay, so that's the kind of compromise you have to come up with. Okay, so let's have that as those three as A, and different people may do different compromise this differently. So there is no one single right answer, but then there could be wrong answers. So because whatever judgment that you make, you should be able to defend it. Okay, this is the reason why I made this into an A and not a B, and you should be able to defend that decision. Okay, now we'll come from the bottom for C items, right? So obviously the last one is C. So how many you want to go? So you want to go up to 70% of the items, 10% of the value. No, that's obviously not going to be possible, because you'll then have only no B's at all. You'll have only A's and C's. So let's look at the dollar value. If you look at the dollar value, okay, so 10% would be about that. Okay, so maybe you can include that as well. So that would be the 10% of value, and that covers only 36% of items. Right? This is 36. Yeah, this is 64. 43%. So maybe some more C's can be added. So here let's look at, this is 180 and 180. So this is definitely closer to a C item than to a B item, right? So what about this? Okay, well, maybe, okay, that's a kind of a judgment call. So we can then do B. So then you end up with 3 A's and 3 B's. Or maybe that would be a B then. So it will have more B's than A's. Remember, A's should be the smallest number. Well, okay. So this seems to be a somewhat reasonable classification. Once again, these classifications are judgment calls. Okay, you don't have a formula that you just plug in and it gives you what the A's and B's and C's are.